Hello everyone, Namaskar, Rajkrishna this side. So let's discuss a small concept of numerical methods, and it is difference of a polynomial. I will not be discussing the full-fledged derivation for this, just the statement of the theorem. That is, the nth difference of a polynomial of nth degree are constant, and n plus 1th difference of a polynomial is 0. Fine. A simple statement is this, because when you make the difference table, then you see when you move forward in table you get two values only, and if you further take the difference, so that becomes 0. Okay, we'll see more of this, and these are some mathematical notations for that. So nth difference of a polynomial fx is an is nothing but the coefficient of the highest degree term. Let's say you have a polynomial of degree 3, so x cube, whatever the coefficient of x cube will be there, that is an, into n factorial. N is again the degree, and h power n. What is h? H is the interval of differencing. I hope you know about that. And if n difference is constant, then n plus 1 difference will be 0. There is a good application of this, interesting one, missing term technique. Okay, so whenever you have been given a data set like this, where you have a set of x values and corresponding to that you have set of y values, this is nothing but in polynomial only we have put the values of x to get some value of y, and we have made a table. Okay, but one such value is missing. As you can see, corresponding to the value of x, we don't have a value of y. So that's what we need to find. So how can we find this? Let's assume this is a question mark. Let's assume this as a. Okay, let's use some different color so that it becomes even more interesting. Now I have assumed this as a. Now, just think that it is not a but some number. So, similar to how you make a table for if this would have been numbers like 7, 9, 13, 21, and 37, similarly make a difference table for this also. Okay, so first difference, why is this happening? Okay, so del of y, first difference, how you make that? A minus 7, then 13 minus a, then you take 21 minus 13, which is 8, then we get 37 minus 21, which is 6, and 10, 16. This was all about the first difference. Fine. This is again not looking good. So what I will do is this. Fine. Let's make y for y2, for y3, and for y4. Fine. So second difference if I need to find, so this is the second difference of difference. So 13 minus a minus 7. Okay, so 13 minus 7 will give you 20, and minus a, so 20 minus 2a, and write this in the middle of this. So 20 minus 2a. Fine. Then this, so 8 minus 13 is minus 5, plus a it will be there, so minus 5 plus a, and here you will get 8. Again take difference, so that will be your third difference. So minus 5 minus 20, minus 25, a minus 2a, minus 3a. Okay, and this will be 13 minus a, and finally one more difference. So this will give you 13 plus 25 is uh 38, and minus a, 38 minus a minus minus 3a, so minus a plus 3a, that means plus of 2a. Okay, let's see it once again. 13, 38 minus a plus of 3a, this will be 30a. Okay. So let's check our calculations once again. So we had initially a minus 7, then 13 minus a, then this would give you 8, and this will give you 16. Then 13, first minus a minus 2, and 13 plus 7 is 20. Then 8 minus 13 is minus 5, and you have 8 minus 13, okay, plus a. Then 16 minus 8 is 8. Then further minus 5 minus 20 is minus 25. And a, okay, here it will be a plus 3a. Okay, so this made, I think, some sort of a difference. So we'll have to look forward to this. So this is 13, 38, it will be there, and minus a minus 3a, so minus 4a. Okay, now comes the funda, that what will we do with this table. So number of non things are there, so the non values, how much non values are there? 1 2 3 4. So whatever will the number of the non value, that order of the finite difference needs to be equated to 0. So because we have 4 non values, so del power 4 y will equate to 0, that is this value only. Okay, had there been 5 non values, then we need to find del power 5 y, that was there. So because we have 4 non values, so this is equal to 0. Now simply equate this to 0. So 38 minus 4a equals to 0, gives you a as 38 by 4, which is 9, and 0.5. Okay, 9.5 is what you are getting. So this is the value of a that we got simply. So now whatever missing, you can replace this by that value 9.5. This is interesting, isn't it? Okay, now what else we can do? Is there any other method in which we don't need to make table? Yes, we do have a method. So because this del power fourth difference, not power, so fourth difference, how we knew that this is needs to be equated to 0, because 4 unknown values, so 4 difference needs to be equated to value. So because we already know this expression, we don't have any thing to do with the table, although it has to do with the table, because this line needs contains this del power 4y, but leave that, because it directly depends on number of known values. So you can always see the question and see the number of known values, and we can directly say that del 4 difference is 0, let's say. Okay, Now here if you see in this line, if I were to say something as roughly, if I draw this inside here, if I draw this, so these are the values, y naught, y1, let me write it, y0, y1, y2, y3, y4, I'm talking in general. So you get something like this. Uh, if I talk about del y, so you get something like the first difference as first difference to del y0. If you subtract y1 and y1 minus y0, okay, then you get del y1, y2 minus y1, and then you get del y2, y3 minus y2, and del y3. Okay, then similarly it is a rough table which I am making. So del second difference, so again you will get write this in the middle. So del 2 y naught, then you will get del 2 y1 and del 2 y2. Okay, then you will get look for the third difference, and there you will get del 3 y naught and del 3 y1. And when coming to the fourth difference, you'll finally get del 4 y naught. So if you look at this line, okay, then you will say that this is to be equated to 0. So what is the expression there? Del 4 difference of y naught. Okay, so if we are having confusion here in y because subscript is not clear, so del 4 y naught is what I'm talking about. Okay, now what we need to do with this, I hope you know one relation between forward difference and shift operator, which is this. Let's use this. So in place of forward difference you can write e minus 1. So e minus 1 power 4 y naught is equal to 0. Now I hope you have some sort of idea of binomial theorem, how to expand. You can also write this as e minus 1 times e minus 1, but if you have the idea of binomial theorem, let's use that. So 4c0, first term, which is e power 4 minus 0, which is 4, and minus 1 power, or what we can do, because the second term is 1 only. So you know that if you are writing x minus 1, if the as and when the power is even, or 1 minus x, that doesn't matter. Okay, so if I write this as 1 minus e, 1 minus e power 4, that will also be similar because I have just taken minus common, and minus 1 power 4 is nothing but 1 only. Okay, so that will not make any impact. And now I know a simpler binomial for 1 minus x power n, that is nc0, that means 4c0. Okay, plus 4c1x, sorry, minus of 4c1x, x here is e, plus 4c2e square. Number of term will be 5, I hope you know this. 4c minus 4c3 minus 4c3e cube plus 4c4e power 4. 5 terms I have written, and operating on equals to 0. Now I have one more result, e power n y power subscript r is y n plus r. This is one result which I will derive some other day, but for today let's only use this result. So why and where will I use this result? 4c0 is nothing but 1. So 1 into y naught, that is simply y naught. No need to do anything for that. Okay, 4c1. 4c1 is 4. You know nc0 is 1. nc1 is n. ncn is also 1. And what else? Okay, these three values. So minus 4 times e times e I can write as e power 1 and then y naught 4c2. Okay, how can we calculate this? Go 2 steps back. So 4 into 3, and in denominator also go 2 steps back. So 2 into 1. So if you simplify this, you are going to get 6. So plus 6 times e square times y naught. Not, this is not times, this is e, this is operator, e is operator, so this is operating on y naught. And next 4c3. Okay, one more result. These are just, we are playing with binomials. So ncr equals to ncn minus r. So 4c3 will be same as 4c1, which we have already calculated to be equal to 4. So minus 4 e cube operating on y naught. 4c4 is 1, so plus e power 4 y naught. Now let's use that for y naught. This is fine. Minus 4 again n r. So whatever the power, whatever is the subscript, add that and write in the subscript of y. So y1, here y2, here y3, and you will see in the pattern also y4. Now you already know the values y0, y0 from the table. So those are 7, a 13, 21, 37. 7, a 13, 21, 27, 27, 37. Fine. So this will be 78 plus 7, that is 85. Okay, 85 minus this is I think 84, that is 1 only. Okay, and 1 plus 37 is 38. 4a equals to 38, giving you again a as 9.5. So this is what we have done tabular form. If I make it a bit smaller, this is the overall picture. First we knew what was the differences of polynomial, a small theorem whose derivation I didn't discuss today. Then the missing term technique. So this is simple because we have 4 unknowns, so value of fourth difference will be equal to 0, that you can find and equate that to 0. And that was method number 1. Method 2, if you wish not to use the table, so just look at the number of unknowns and that much difference equated to 0. Use this relation, which is the relation between forward difference and shift operator, and this relation also, and some easy binomial expansions to get to your answer. If you don't wish to make table, so you can use the other method as well. So tabular was the first method and this was the second method in case you wish to find the number of missing values. Okay, everything depends on number of known values, and if you know number of known values, you can always play with this. So that's it for today. We'll see you with some more problems like this. Thanks again.